Hello everyone, it is Dr. Christopher Groot here. I am making this video to help you with assignment 2, and specifically I want to help you with the results section and the creation of your figures to answer the hypotheses that you have posed in assignment 1. Of course, as part of assignment 1, you were posed 3 research questions, and you needed to convert these research questions into very specific and testable predictive statements, hypotheses that you would then test in the data through visual inspection of the figures that you plot. And I'll show you those, how to plot those figures today. So the first question here is about age, the second question was about gender, and the third one was a little bit more complicated and asked us to think at maybe a more comprehensive and higher level about whether or not older and younger children use different mental models. The first question, I suppose, depending on your reading, could have gone either way, but most likely the evidence that you found in the literature would have suggested that a plausible prediction would be that older children would use a sphere model more often than younger children, or older children would endorse a sphere model of the Earth more often than younger children, or you might have phrased it in terms of proportions or percentages. You might have said, for example, a higher proportion of older children would endorse a sphere model of the Earth when compared to younger children. So why don't we explore that research question first? Let's go back to the Excel spreadsheet, and you've got this spreadsheet on the LMS. And you can see Dr. Humberstone has very kindly presented this data in numerous ways. When we consider which of these data to use, we need to think about a couple of things. Firstly, we need to think about group size. Now, there are certainly different group sizes, different sizes in terms of the number of people in the younger and the older category. So rather than deal with raw numbers and frequency data, which would skew our results and give us some misleading findings, because to a point those findings would be based on the unequal group sizes, we will use percentage data instead. So let's think about this hypothesis. We have most likely predicted that older children would, or a higher proportion of older children would endorse a sphere model when compared to younger children. There are different ways in which you could look at this hypothesis about older and younger children differing in terms of a scientific understanding of the Earth. Now, when we talk about a scientific understanding, again, we're talking about the sphere model. So I suppose at a fundamental level, we would want to know about what percentage of young children endorsed a sphere model and what percentage of older children endorsed a sphere model. So that is really easy to do. We could look, and you've got all different types of tables here, but one way that you could plot a figure to investigate this particular hypothesis is by coming down here to the table that has the percentage of sphere and non-sphere responses given by younger and older children. Now, in its simplest form, this hypothesis could be addressed by just selecting this data here. the sphere data, the scientific understanding of the Earth shape data for younger and older children. If we plotted that or graphed that, then we could compare the percentage of younger children who gave a sphere model response along with the percentage of older children who endorsed a sphere model as well. So let's do that. We can create a figure, a graph very easily, and then we can really easily import it into your Word document simply by highlighting the area that we want to we want to plot and create a figure out of, and then going up here to Insert, click on Insert, and you'll see it opens up a range of options. We want to insert a chart or a figure, and the type of chart that we are going to insert is one of these, a column chart or a bar chart, and for your purposes you would choose a clustered column chart. So let's select that and see what happens. So we've selected that, and I will enlarge this figure. What we can see here now, I'll make it even bigger, is that we have a column for younger children and a column for older children on the x-axis, and on the y-axis we've got the percentage of those children that endorsed the sphere model. And of course I know what is on the y and the x-axis because I just made the figure based on this data here. But to your reader, the person that's marking your lab report, they won't know what's on the y-axis or what's on the x-axis, what's on the vertical axis in other words, and what's on the horizontal axis. You're going to need to tell them. You're going to need to label your axes. And there's a few things that you could do to this particular figure to bring it up to APA style. Let me give you a couple of hints. Firstly, you might want to adjust the font size and the font type. We might want to get rid of this title as well. An APA style figure does not have a title here, so we'll get rid of that. And you can modify any particular element of a figure in Excel just by clicking on it. As you can see me doing here, we can see that every time I click on a certain aspect of the figure, things are lighting up. So let's click on the title and get rid of that. We'll just click delete. Once we've highlighted it, title is gone. The next thing are these crosshatches. Now, strictly speaking, these aren't APA style, so we could get rid of those too. Even though they are helpful, and there's certainly an argument for retaining them, in terms of strict APA style, we need to get rid of those. So I've highlighted them, and I can now just click delete, and lo and behold, they are gone. Now we need to label the horizontal or x-axis and the vertical or y-axis, and we could do that by adding a chart element up here in the top left-hand corner. So we'll click on that, and we can see we can add axis titles. So let's start with the primary horizontal axis, and we can see it's just inserted a default title here, but we will change that to how about we call it child age group or something like that. So we've got a label that tells us about what is on this horizontal axis. We've got younger children and older children, so child age group is a reasonable axis title to have here. Next, we could put a title axis, an axis title on the vertical or the horizontal axis, and again it's put in a default title, and we will delete that text, and we can say maybe percentage of children endorsing a sphere model. Oh, a sphere model. There we go. So then we've got the start of a good figure that we could copy and paste into a Word document. I'll leave you to go and look at the APA styled guidelines about exactly how you might want to work with this figure more to really bring it up to scratch and have it really polished for your document. But this is a basic how-to. Now, to put this into your document, it's really simple. You would just click on it and right-click and copy. So let's copy our figure, and then let's go to a Word document. So I've got a Word document here, and we can see that I've done a mock results section here. And of course, if you were writing your results section, you'd have a results header as appropriate at the top here. And then you would introduce the analysis for your first hypothesis. And this is the one that we've just made the figure for, the hypothesis about age and the scientific model of the Earth. So again, you've probably predicted that older children will endorse a sphere model more often than younger children, or a higher percentage of older children would endorse a sphere model than younger children. You'd then go on to talk about how you prepared the data for this analysis. And what I mean there is when you look back at these, dearie me, bear with me. When you look back at this data that we've plotted, you need to think about, from the raw data, what exactly has happened from the point at which the raw data was collected to this point. And of course, we have converted the raw data into percentages, and then we've just selected the sphere data for the younger and older children. So you'd talk about that, and then you'd say that the data for your figure for this particular analysis is presented in, and it would be figure 1 for the first hypothesis. So this is probably where we would paste our data for figure 1. So I'm just going to click in here, and I'm going to right click, and I'm going to say paste. And this is a very slow computer, sorry, bear with me while this happens. And oh my goodness, we've got an extremely large figure there that we could certainly make smaller just by clicking on the figure and then dragging it up and maybe making it a bit smaller. We can make it a bit bigger than that. And of course, you would need to label this figure, give the figure a title, and again, I will leave you to have a look at your APA style guide about exactly how to do that and to read up on that. But that is how easy it is to get a figure into your Word document from Excel. If you replicated that process precisely, then you would have your figure in Excel for your first hypothesis. So remember, your hypothesis was that potentially that older children would, a higher percentage of older children would endorse a sphere model when compared with younger children. And if you have a look at this pattern here, I suppose you'll have a think about exactly what that is telling you. Here we've got less of whatever this is than this, and that's exactly what you could write down here. So you could then say, you know, figure shows that there are, and it's obvious, isn't it? There are more older children, a higher percentage of older children endorsing a sphere model than that of younger children. So that's what you could report down there. Pretty simple, really, isn't it? And that's how to report, basically, on the first hypothesis. Your next hypothesis dealt with the gender question. Depending on the literature that you found, you may have predicted that a higher percentage of males would endorse a sphere model of the Earth, or a higher percentage of females would endorse the sphere model of the Earth when compared with the opposite gender. And again, we can very easily examine the evidence for this in our Excel spreadsheet and create a figure. So let's have another look at our Excel spreadsheet, and you can see I've got a section here prepared ready to go for figure 2 for our second hypothesis. And you can see, well, you would have seen that it's just really repeating what we've done here with the age figure. This time the difference is going to be that instead of comparing younger and older children, we're going to be comparing males and females. So let's click on the gender tab here. And again, you can see that there are a range of tables that you could choose from to plot your data. But again, we're not going to use raw count data or raw frequency data. We are going to use percent data, and we might as well adopt a consistent approach to that which we did with age, and we'll come right down to the bottom here, and we can just look at the sphere model data for males and females. So here we have the percent of females who endorsed a sphere model and the percent of males who endorsed a sphere model. So what we can do here is, again, highlight our labels so we can get our headings for our categories and our axes really easily, and the data that we want. Now remember, in its simplest form, our hypothesis here could be, for example, that a higher percentage of females would endorse a sphere model when compared to males. And all we need, therefore, is the sphere model data. So let's highlight that as we have. We'll go up here again to insert, and we will insert another bar chart, one of these clustered column charts that Excel calls it. And here we have a new figure, and this is males versus females. Now you can see here that it looks like there is a difference, and you probably heard my moment of pause when I first made the figure. Now Excel can be a trickster. Excel's not completely ethical, shall we say. And Excel has an algorithm built in such that when a figure is created like this, the algorithm will create a figure based on the data such that it draws out visually any sorts of differences. Now, the question we have to ask ourselves when we look at the raw data here is it really a meaningful difference between 83.55 and 82.12% of people? We're talking about basically maybe 1.5% difference roughly. It's basically nothing. It's not meaningful, is it? Even though we're not doing statistical analyses, we can sort of use some common sense around this. That, if roughly 83 to 82% of females and males respectively are endorsing a sphere model, it doesn't seem to be much of a difference. So Excel is playing with us. We can, however, keep Excel honest. Let's go back to our age figure and have a look at the scale on the y-axis. You can see it goes from 0 to 100%. It would be good if you maintained the same scale throughout all of your figures, and I would suggest that the 0 to 100% is the most appropriate scale. So how has Excel drawn out this what we would say this lie effect. It's used a lie effect. It's sort of drawn out this illusory difference between the genders. It's done it by manipulating that scale, and you can see that its scale on the y-axis doesn't go from 0 to 100, it only goes from 81 to 84. So we would want to change that. And we could change that again just by clicking on it. Remember that there are numerous things that we can change about the figure to bring it up to APA style. Again, you could get rid of this title. You'd want to do that, so we'd delete that. We'd delete the crosshatches. Sorry, here we go, the crosshatches. We would insert title axes. Let's do that. So our primary horizontal axis in this case, if we think about what is happening on the x-axis, we've got gender, don't we? Males and females. So let's call this gender. And then on the y-axis, or the vertical axis, again, we've got the percent of children, endorsing a sphere model. So that's a good start. We also need to fix up this scale. Now it's been a while since I have changed a y-axis scale. I've double-clicked on it, and it's pretty intuitive. If we go up here to bounds, we can see that the minimum bound, or the lowest point of the scale, is 81, and the maximum bound is 84. So if we change this from 81 to 0, and from 84 to 100, we are now consistent with figure 1 in terms of our y-axis scale, and all of a sudden this tells a very different story, doesn't it? Now when we look at the figure, this tells a story of there really not being much of a difference there. I'll let you make up your mind about that and how you interpret it. Again, to get this into your Word document, all you need to do is right-click on this, maybe on the corner, copy, go to your Word document, and paste it in. So again, we can just click on this and make it a little bit smaller, just for the sake of the example. So just for the sake of the example again, we've got an introductory section of text. You want to have that, so you want to introduce that you're now talking about hypothesis 2 and talk about again how you prepared the data for analysis. So did you convert frequency data to percent data? Were any rows of data combined, and so forth? This is certainly what you could do here. And then you'd say, you'd refer people to where the data is that you're going to analyze, and say that it's below in figure 2, and here is what you'd call figure 2, and you'd have a title here in APA style saying figure 2 and describing what it is. Again, I'll leave you to read about that. But there is your figure. And again, you wouldn't just leave it at that. You'd then go on to interpret the figure. And I will leave you to interpret that. I don't want to make this too easy for you. This is your assignment after all. But it's just a matter of looking at this figure, doing no statistical analysis, and all you need to do is interpret what you are seeing here. And that is how easy it is to report. For now, we've done hypothesis 1 and hypothesis 2. Your third research question is a different type of question. Instead of just comparing two different age groups or two different genders on just the sphere model of the Earth, this is asking us to examine all of the possible Earth models as a function of younger and older children, and see basically if there is a different pattern of model use by younger children when compared to that of older children across all of the Earth models. So this is a little bit more complicated. To produce a figure to investigate this third hypothesis about younger and older children and which particular types of conceptual models of the Earth that they endorse, we need to firstly come to the Age tab. This would be a good place to come, the first tab in the worksheet that's available on the LMS. And there are two tables here in particular that we could use. Now, again, the choice is up to you, and it's fine to take either approach. You just need to be clear about why you're taking a particular approach and clearly detail in your results section which approach you took as regards, were you looking at the total amount of responses made by either younger and older children broken down by model of the Earth, or did you instead look at the total amount of responses for each model of the Earth broken down by younger and older children? For the purposes of this video, and to give you an example about how to make the figure for this hypothesis, I'm going to use this table here. So I'm going to highlight the data, and again I'm going to go up to insert, and I'm going to insert one of those bar charts again, and here is the chart that comes out. So we have the different models on the x-axis here, and then we've got the percentage of responses made for each of those models by younger and older children on the y-axis. So the again, the younger children are in blue, the older children are in red. What you could do is look at the trends, and there does seem to be a different trend when you look at the data in this particular way, doesn't there? Now, I'm not going to go into interpreting this particular trend. You've seen me now really give you a good idea about how to interpret the last two hypotheses and how to paste them into your Word document. You'd do exactly the same with this chart. You'd prepare it according to APA style, and then you would copy and paste it into your Word document in the appropriate place. Again, you'd have that introductory text explaining which data you chose to analyze, and in this case we have, for this particular figure, chosen the data that looks at the total proportion of responses for each model of the Earth broken down by the age of children, younger and older. And you can see that the red trend sort of dips down across these models, and the blue trend sort of goes up, doesn't it? So I'll leave you to have an inspection and a think about what that might be. Again, you would just take this, once you've prepared it, paste it into your Word document, and then you would have the figure for your third hypothesis. You'd speak to that figure once you've inserted it and describe what you see going on, and then that is your results section completed. I certainly hope that this video has been useful for you and you found it helpful in creating your assignments. I've certainly received a lot of questions about the assignment, so I hope that this answers a lot of those questions and shows how easy it is to actually work with the data that you are using. So again, good luck with your assignment, and we look forward to seeing your work and to reading it.